Hi, welcome back. So this is our sample problem last time, and let me discuss further the integration part, this part here. So after we separate and come up with a separable equation, then we need to integrate this each terms, the x and y terms, right? And we come up with this solution. So some of you might think um, how is that gonna happen? What happened here in integrating these terms? So I assume that you already know how to integrate this term, but let me do the step-by-step process on how to integrate these terms in x and in y's. Okay, so let me rewrite this first. So we have the integral of x dx all over uh, 1 plus x squared, and then plus the integral of y dy all over 4 plus y squared is equal to 0. Okay, because some of you might ask how to integrate this part. So our technique here is to use the change of variables. So we need to let some variable, say for this part, let variable u is equal to 1 plus x squared. Then let's take the derivative of u, which is du, and the derivative of this part, derivative of 1 is just 0, plus the derivative of x squared is 2x dx. Okay, and let's now go back to our integrand. So we have x dx here and 1 plus x squared. We can now we now know that the 1 plus x squared here is this part. So we can now substitute the value of this in terms of u, and for the x dx we have x dx here. So we need to divide this both sides by 2. So we have du all over 2 is equal to x dx. Okay, by doing that, we have here the integral of our x dx, once again, is du over 2 all over the 1 plus x squared is equal to u. So we have du over 2 all over u, or we have 1/2 du over u. And by integrating this part, du over u is ln of u. So we have 1/2 ln of u, ln of u. And then we need to bring back the value of our u, which is 1 plus x squared. So we have 1/2 ln of 1 plus x squared. Then this is now our integral for our first part, x dx all over 1 plus x squared. So the same technique can be used in our second part, the integral of y dy all over y all over 4 plus y squared. So we need to let do some variation of variables here, or the algebraic substitution. So we have to let some variable, say let's use variable m, is equal to this denominator 4 plus y squared. Then by getting the derivative of this, derivative of m is dm, and derivative of this part is 2y dy. Okay, then let's now check if we can now transform all our y's in terms of m. Okay, so by checking, we have 4 4 plus y squared, which is equal to m, and we have here y dy, and we have here y dy already, but we need to divide these both sides by 2 so that dm all over 2 is just equal to y dy, and we can now simply use or substitute the variable by having y dy is equal to dm all over 2 all over 4 plus y squared, this part here, is equal to m. So we have this part. And then we have 1/2 integral of du over dm over m is equal to 1/2 ln of m, wherein the value of our m is this. So we have 1/2 ln of 4 plus y squared. Okay, then our c. Okay, so that is the integration part of this integral. Okay, but if you can just um, do it mentally by not doing this step, then you may do so as long as you understand the problem and the solution and the integration. Okay, so that's all for this video, and see you on our next example.